In the world of math, some things just feel wrong. Today, we're going to tackle one of the biggest head scratchers out there, a statement that seems completely impossible on the surface, but is actually built on the very foundation of how we understand numbers. So get ready, because your intuition is about to be seriously challenged. Okay, let's just dive right in. Take a look at this number, 0.9, with the nines repeating forever and ever. Now, my question to you is really simple. What does it equal? What's your gut telling you right now? If your brain is screaming, well, it's almost one, but not quite, hey, you are not alone. That is the most common, the most intuitive answer. But here's the twist. The proven mathematical answer is that 0.999 repeating is exactly 1. I'm not saying it's close to 1, it's not approaching 1, it is 1. And to prove it to you, I'm going to walk you through 3 completely different, undeniable arguments. So let's start with the classic. This is, for a lot of people, the most convincing proof. It's just a few lines of really simple, kind of elegant algebra that's going to pin this concept down perfectly. Okay, let's break this down step by step. First, to even work with an infinite number, we've got to give it a simple name, right? So let's just call it x. Now, watch this move. If we multiply our x by 10, the decimal point just slides one spot to the right, giving us 9.999 repeating. Now here's the really clever part. We subtract our original x from this new number. On the left, 10x minus x is, well, 9x. And on the right, this is the cool bit. All those infinite nines after the decimal point just cancel each other out perfectly, leaving us with just a clean 9. And that leaves us with a super simple equation, 9x equals 9. From here, the final step is pretty obvious, right? Just divide both sides by 9, and what do you get? X equals 1. And remember, we started this whole thing by saying x was just another name for 0.999 repeating. So through pure algebra, we've just proven they have to be the exact same thing. I get it, though. For some people, that algebra proof can feel a little bit like a magic trick. So if you're still skeptical, let's come at this from a totally different angle. This time, let's try building the number from the ground up, using the idea of an infinite sum. Think about what 0.999 repeating really is. We can actually break it down, right? It's just 0.9 plus 0.09 plus 0.009 plus 0.0009, and you just keep adding those pieces on and on forever. Each piece gets 10 times smaller, but the chain itself is absolutely endless. Now, this kind of infinite sum has a special name in math. It's called a geometric series. It might sound complex, but the idea is simple. It just means you have a starting number, and then you multiply it by the same common ratio over and over again to get the next number in the line. So here's the really cool part. Mathematicians figured out a powerful little formula to find the exact sum of a series like this. All you do is take the first term, a, and divide it by 1 minus the common ratio, r. In our case, that first term is 0.9, and the ratio we keep multiplying by is 0.1. So we just plug those values right into the formula. 0.9 divided by 1 minus 0.1. And just look where that takes us. 1 minus 0.1 is, of course, 0.9. So our calculation becomes 0.9 divided by 0.9. And, well, any number divided by itself is just 1. So there you have it. We used a completely different method, and we still landed on the exact same conclusion. The sum of all those infinite parts doesn't just get close to 1, it converges precisely to 1. All right, 2 proofs down, 1 to go. But now let's tackle the real source of all the doubt, right? That deep, intuitive feeling that there has to be some tiny infinitesimal gap between 0.999 and 1. This final proof is going to address that feeling head on.
This is really the question at the heart of the whole debate, isn't it? It just feels like you should be able to get infinitely close to something without ever actually being that thing. So, you know what? Let's put that intuition to the test.
Let's think about it this way. Can you name a number that's between 0.9 and 1? Yeah, of course. Easy. How about 0.95? Done. Now try to do the same thing for 0.999 repeating and 1. Oh, wait. Can you name a single number that fits in that so-called gap? The thing is, you can't. If you try to add any digit at the end, say 0.9995, you've just broken the whole pattern of infinite nines. There is literally no space on the number line to place another number between them. And this brings us to a fundamental rule of how numbers actually work. In the system of real numbers, if you can't find any space, if you can't squeeze another number between two values,
then they aren't two different numbers at all. They are just two different ways of writing the exact same thing. That gap that you feel should be there, it's just an illusion. So, after looking at this from three completely different logical angles, what have we really discovered here? We haven't found some weird paradox in math. We've simply found two different name tags for the exact same value. So let's just recap really quick. Our first proof used some simple algebra to show that our number had to equal 1. Our second proof built the number piece by infinite piece, and the sum converged exactly to 1. And our third proof showed us that there's simply no room, no space at all, between them on the number line. Three different paths, all leading to the same undeniable destination. And that's really the key takeaway here. The numbers 0.999 repeating and 1 aren't neighbors on the number line. They are two different names for the exact same address. It's a concept that really shows how the pure logic of math can sometimes be way more reliable than our own gut feelings. It kind of makes you wonder, what other intuitive facts do we all take for granted that might not actually be true at all? Thanks for joining me on this one.